Hello students, I hope you all are doing good. Now we'll start with our next problem. The next question is x cube plus x squared y plus xy squared plus y cube is equal to 81. So same as usual, we have done our previous examples. We are writing what we have, differentiating with respect to x. So be d by dx, x cube, d by dx. Differentiating means this, yes, this is a differentiating denoting. So d by dx x square y, d by dx x y square plus d by dx y cube is equal to d by dx 81. So we will differentiate. So here you see it is d by dx x cube means what? Whichever formula come, it is kind of x raised to n. So differentiation of x raised to n is n x raised to n minus 1. So same way my n is what? 3. So 3 x raised to 3 minus 1 is 2. Okay. So here you have u into v rule, right? It is x square into y. So you have u into v. U into v formula is what? U differentiating your v plus v differentiating your u. So you have to apply in this way. Even for this you have the same uv formula. You have to apply product rule. So we're going to see u, here I am taking u as x square, so keeping my x square, differentiating y, differentiating v. Now see, here it is y. So differentiation of y will be what? Dy by dx plus keeping my v. Here v is what? Y. Keeping my v as it is, differentiating u. U is what? X square. X square again it is in the form of x raised to n, which is an x raised to n minus 1. So it will be 2x. Why 2 minus 1 will be 1 itself. This plus same differentiating the other part, u into v, keeping u, differentiating v. It is y square. Y square means first we have to go for x raised to n form. It will be how? 2 y raised to n minus 1. 2 minus 1 is 1. Again interior differentiation of y will be dy by dx plus your y square, keeping differentiation of x is 1. Yes, I hope you have understood this product rule. Again plus and differentiation of y cube. Again y cube is in the form of x raised to n. So it will be 3 y square, 3 minus 1 is 2, and again interior of y, because y has taken the place of x, right? So again you have to differentiate it. So it will be dy by dx. If it was x, then no need of taking dy by dx. Why? Because you are differentiating with respect to x. So it will be dy by dx is equal to 0. So now what we will do, our dy by dx terms we will group up in one part, and without dy by dx we'll take it to the other side. Here you can see you have 1, 2 and 3. 3 terms of dy by dx I'll keep it in the left hand side, and here you can see 1, 2, 3. 3 terms, that is without dy by dx I'll take it to the right hand side. Okay. So here you can see I have kept my 3 parts of dy by dx at left hand side, and the other I have taken to the right hand side. So x square dy by dx plus 2xy dy by dx plus 3y square dy by dx is equal to, when you are taking it to the right hand side, all the positive terms becomes negative, right? So plus 3x square becomes minus 3x square, plus 2xy becomes minus 2xy, and plus y square becomes minus y square. Okay. Now you see in this 3 also what is our common? Dy by dx, because we have to find the value of dy by dx. So we have to take dy by dx outside, keeping dy by dx. Remaining terms are what? X square, 2xy, 3x square. So I have written that only x square plus 2xy plus 3y square is equal to, in this 3 also our common is what? Minus sign. So keeping your minus outside, I'll be left with 3x square plus 2xy plus y square. If you're taking minus common means inside everything will be plus, right? So now my dy by dx value, what I'll get? The whole term divided by this. So it will be minus 3x square plus 2xy plus y square whole divided by this when it comes to the down, that is x square plus 2xy plus 3y square. So this is your final answer. Next question we'll see. Next question you see, sine square y plus cos xy is equal to k. Same way we have, see if you are not understanding, if you have like this sine square, even you can write it like this, sine y the whole square plus cos of xy, here I have made again bracket, is equal to k. So that you can understand while differentiating it will be clear for you. So differentiating with respect to x, d by dx sine y the whole square plus d by dx cos xy is equal to d by dx k. So we'll see the differentiation. Here you see it is sine y the whole square, means you have 3, right? Chain rule I've said you have here your square, then you have for sine, and then interior you have for y. So you have your 3 parts. So first for square we have to do, that is what our x raised to n part. X raised to n is what? N x raised to n minus 1. So it will be same 2 x raised to n minus 1. So 2 sine n minus 1. 2 minus 1 is 1. So that part is over. Yes, your x square part is over, x raised to n part is over. Left is what? Next is your sine y, right? So next is your this part, sine part, sine y. Sine y differentiation is cos y. So cos y, and again y you have, again differentiating y. Y differentiation is dy by dx. understood? First of the square, then comes your sine, and then comes your y. So the same way we have done x raised to n part, that will be 2 sine n minus 1 is 2 minus 1, sine y is cos y, and differentiation of y is dy by dx. Now again next you have here also same, you see, differentiation of cos xy. First whole differentiation, and again then here interior differentiation. Here interior differentiation. So differentiation of cos is minus sine. Plus I have written this as it is first. Cos differentiation is minus sine x. X term is taken by what? X and y. And again differentiating x and y. Here x and y, it is how? Product rule. UV. It is UV rule. So again we'll go to our UV rule. Again interior differentiation, you have to differentiate in UV. Keeping your x, differentiating your y. With respect to x means it will be x dy by dx, plus keeping your y, differentiating x is 1 equal to differentiation of k. This is constant, right? So constant term will be 0. Differentiation of any constant 0. Even in your previous one you had 81. Differentiation of 81 will be what? 81 is a constant, so it will be 0. So your next step, here you can see 2 sine y cos y, I have written as sine 2y. As you have the formula, you have the formula sine 2 theta is equal to 2 sine theta cos theta. So same way you have 2 sine y cos y is sine 2y, and dy by dx. So here minus, now you have to multiply it for both. See, this is for both, right? So I'm just taking it inside. Minus sine xy x dy by dx, minus into plus is again minus y sine of xy. So you have got this. Now in the same way, dy by dx part keep one side, and which is not with dy by dx, take it to the other side. So I have kept sine 2y dy by dx minus x sine xy dy by dx at one side is equal to this. I have taken to the right hand side, so minus becomes plus y sine xy. In this both, what is my common? We have to find for dy by dx, right? Dy by dx, if I keep common, I'll be remaining with sine 2y minus x sine y. You are having this is equal to y sine xy. I have to find dy by dx, so dy by dx will be y sine xy whole divided by sine 2y minus x sine xy. So this is your answer. Please go carefully, go thoroughly, and then solve it peacefully. Understand first differentiation, understand when you have to use your product rule, your quotient rule, and solve it. I have given you here few formulas. Please note it down, and again few formulas I'll give you which you have to find out and write it. Make these formulas because it is very useful. Just few formulas I've written which I'll tell you. Sine 2 theta you have in two forms. One is 2 sine theta cos theta, and in terms of tan theta also you have, that is 2 tan theta whole divided by 1 plus tan square theta. Then you have cos 2 theta. Cos 2 theta you have many formulas. You have cos square theta minus sine square theta. You have 1 minus 2 sine square theta. You have 2 cos square theta minus 1. In terms of tan, it is 1 minus tan square theta whole by 1 plus tan square theta. Then you have tan 2 theta. It is 2 tan theta by 1 minus tan square theta. Tan 3 theta, 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Sin 3 theta, which is 3 sin theta minus 4 sin cube theta. Cos 3 theta, which is 4 cos cube theta minus 3 cos theta. So write down these formulas because it is important. I have just given you few formulas. Few formulas I'll give you. Write it down. It is your homework. 1 plus tan square theta, find out 1 plus cot square theta, 1 minus cos 2 theta, 1 minus sin 2 theta, 1 plus sin 2 theta, 1 plus tan theta whole divided by 1 minus tan theta, 1 minus tan theta whole divided by 1 plus tan theta. Find out these formulas and write it down, and how much I have given, that also you write, and leave one page, write it whole. We'll go to our next problem. We'll go for next problem. Before going next problem, it is inverse trigonometric part. Inverse trigonometric, even formulas also I have given you. See, inverse trigonometric, what we tell is, you have a chapter of your inverse trigonometry, a second chapter. I don't know in that how it is. Normal, you have this y is equal to f of x. So this is your normal, y is equal to f of x we tell. So we have a normal trigonometric part, you can tell it if you are using the trigonometric ratios. Like here I have taken as x is equal to sin y. So this is our normal trigonometric function. But usually see, you will be having y is equal to f of x. So here in trigonometric, the sign is given for your y, not for your x. Your y should be equal to it. So to get rid of y, if I want whole term in a y, so this comes it to the other side, means it becomes sine inverse of x. So inverse trigonometric means just this differentiating. It's just you are taking it to the other side and making your y free. If it is your f, your inverse trigonometric is f inverse. You tell like this, f inverse. So trigonometric part always you have to do in such a way. If they are mixing up like this, if they are mixing up and giving, you have to separate it in such a way, keeping your y term and taking your x term apart with your trigonometric, any ratio which they have given, cos, sine, anything. If it is x is equal to sine y, your y will be sine inverse of x. Now suppose if you have x is equal to tan theta. So if they ask what is theta value, in this what is theta value, so it will be tan goes to the other side means it becomes tan inverse x. It's just that. When you're taking it here, it will be inverse, tan inverse x. As you see, you get 2y is equal to x. So if I am finding y value, you will be right x divided by 2 it becomes, now 2 goes down. So y value is x by 2. If you have in your trigonometric ratios, this will be same. When you're taking it, it becomes tan inverse x, just as that. So we will be making use of this. Next is your trigonometric related problems. So we're gonna say it. So here you can see the question is y is equal to sine inverse of 2x by 1 plus x square. So whenever you have a trigonometric and you have here your sine inverse, so in your inverse trigonometric functions, what it tells is you have to make this interior part, your any interior part, get it in the form of sine, because your sine inverse and sine get cancels, your reciprocal and your whole number get cancels, right? For example, if you have 1 by 2 into 2, 1 by 2 into 2, your 2 get cancels, you are remaining with only 1. So in the same way, when you have sine inverse, your interior also you have to do. If you have sine inverse into sine, so if you have sine inverse into sine, so this sine inverse sine get cancels and you'll get the one value. So whenever you have now in your sine inverse, in your inverse trigonometric, if you have such question, make sure first you have to solve it and then go for the differentiation. So here you have sine inverse of 2x by 1 plus x square. So this will get in the form of a sine. How you have your formula? Now only we have done the formula, that is sine 2 theta. I have shown you sine 2 theta in terms of tan, how it is? Yes, 2 tan theta whole divided by 1 plus tan square theta. You have this formula, so we can make this in such a form. So for that, what we have to do? So you have to do, so we do put x is equal to tan theta. So y is equal to what it becomes? Sine inverse. So here you can see put x is equal to tan theta I have done. So in place of x I am putting tan theta. So y is equal to sine inverse 2 tan theta by 1 plus tan square theta. So you have this formula, what it is? Sine 2 theta is equal to tan theta by 1 plus tan square theta. So in place of this, this changes to sine 2 theta. So here you can see this is sine inverse and this is sine. You are getting both opposites. So the sine inverse and sine get cancels. You will be left with what only? 2 theta. So you have 2 theta. So after coming here, now to differentiate, here we need in the term of x, right? Directly you can't differentiate. So x term where you'll get? Theta value you have to put from here. Your x is tan theta. Theta will be tan inverse x. Your tan goes here, so it becomes tan inverse x. So 2 tan inverse x. Now we do the differentiation. Now we have simplified it and we have got in a normal. So we are doing, after coming here at this point, we will differentiate. Whenever you have such problems, simplify it, then you have to differentiate. Differentiating with respect to x, dy by dx is equal to 2, just skip it, 2 into, see here you can apply your UV rule only, as I have said you. I know, because when you do this, constant will be 0, so directly I can do it, keeping your 2 as it is and differentiating your tan inverse x, again 2. So differentiation of tan inverse x, go to the formula and you can see differentiation of tan inverse x is 1 by 1 plus x square. So your final answer you will get dy by dx is equal to 2 divided by 1 plus x square. Whenever you have such problems of your inverse, first simplify it. If you have cos inverse, make sure you get in a cos. If you have cot, make sure you get your cot and just cancel out everything. Remaining part, replace your theta with your inverse x and then differentiate it. So this is your final answer. Thank you.